Hi, in this video we will mainly talk about average kinetic energy for gas molecules. Now when we talk about any gas, so in gas the particles have quite a lot of random motion. Because of that we cannot find their absolute kinetic energy. So in such cases experimentally it was found that the average kinetic energy is given by 3 by 2 kT, where K is called as Boltzmann constant. Now there is one more counter formula for that kinetic energy is also given by 3 by 2 nRT. Now using these two formulas we need to understand that how we need to use them in the questions, how we can equate them, and how the Boltzmann constant was actually calculated. Okay, so let me tell you the value. That the value of Boltzmann constant is 1.38 times 10 to the power minus 23 joule per Kelvin. Now this is a value and we have a valid reason that how it got calculated. So let us try to understand that. So we know that the number of moles are always given by the number of particles divided by Avogadro number. Now the value of Avogadro number is 6.022 into 10 to the power 23 particles. So let's say if I put this value over there in the 3 by 2 nRT, so I will get kinetic energy as 3 by 2 capital N over Na R times T. Now R is also a constant which is also called as gas constant. So here the value of R and Na, both of them being constant, is calculated as K. So from here I got the value of Boltzmann constant, which is K. Let me write it down as Kb so that it may not get confused with kinetic energy. So the value of Boltzmann constant is given by R over Na. Now we know that the value of R is around 8.31 joule per Kelvin per mole, and the value of Avogadro number is 6.02 times 10 to the power 23 per mole. So when you divide this, you will get the value of Boltzmann constant, which is visible over here. So this is the first thing, that this is how we got the value of Boltzmann constant, and in doing that we have eventually understood a kind of formula for Boltzmann constant, which is given by R over Na. Now for questions we need not calculate this ever, because mostly in the questions this will be given as 1.38 times 10 to the power minus 23. So we need not even remember this value. But just for knowledge we should understand that how we got it. So I hope that this part is clear. Now let us try to understand that how we can apply that in the question. Before moving towards the question, you need to understand one more thing, that normally if you look at the formula for kinetic energy, let me write it down over here one more time. So kinetic energy is equal to 3 by 2 kb times T, or that is also equal to 3 by 2 nRT. Now when I replace the value of N, the number of moles, by number of particles over Avogadro number, eventually that became my K value. So it can be noticed that the value of kinetic energy will be 3 by 2 times N times R by Na times T. Now this R by Na can be replaced by K, that is the Boltzmann constant. So this is the average kinetic energy for N number of molecules. N are the number of molecules of gases, which will be mainly given in the question, and if not then we can consider the value of N as 1. So when we consider the value of N as 1, then we get that formula, which is quite a famous one. Okay, so this is how we get the formula. Now it is time to apply these concepts in a question. So let us see the question now. Now in this question, as we can see that it is given that 2 moles of gas is sealed in a container. So the value of small n is 2 and temperature is 47 degrees Celsius. Now first thing we need to understand that the general unit, the SI unit for temperature, or the fundamental unit of temperature, is not degree, it's Kelvin. So we need to just add 273 to it and get the answer. So when we add 273 to 47, we get 320 Kelvin. Okay, now the first part of the question is the average random kinetic energy of the particle in the gas. Now what is the formula? So the formula is 3 by 2 K T. Now just try to, now as we see in the question, that average random kinetic energy of the particles in the gas. So this thing you need to understand, that whatever is the number of moles given, when we are finding average random kinetic energy of the particle in a gas, this is mainly found for per particle. or basically I can say per mole. So whatever is the number of mole given, that really doesn't matter when we have to find the kinetic energy. Okay, someone can think that for kinetic energy, if I use this formula, then what will happen? You can definitely use this formula, but then you have to use the value of R directly over there. Okay, so just try to understand that, directly use Boltzmann constant, plug the values, and you get your answer very easily from here. So it will be 3 by 2. Boltzmann constant is 1.38 times 10 to the power minus 23, and the temperature is 320. When you will solve it, so the value of kinetic energy will be 6.6 times 10 to the power minus 21 joule. So this is how we can get the average kinetic energy of the particle in the gas. This is a noteworthy point, that when we are finding average kinetic energy, then in that case it's by default per mole. So whatever is the number of moles they have given, please don't take that number of mole, directly use this formula and get the answer. I hope that is clear. Now we are moving on to the second part of this question, where we need to find internal energy of the gas. Now the point to understand over here is that when they say internal energy, okay, so this internal energy of the whole gas, okay, and kinetic energy, average kinetic energy of the particle of the gas, what is the difference between them? When we are taking average kinetic energy, then we do not consider number of moles. But when we have to consider internal energy, which is given by U, so that is given to us as 3 by 2 nRT. Now they both are energy, so please don't get confused. When we say average kinetic energy, it is just basically for 1 mole or 1 molecule. That's why over there the mole was not considered. So this is the fundamental difference between average kinetic energy and the internal energy. They look similar, but they are not. So try to understand the difference between both of them. So here we are going to use this formula, and rest is just we need to plug the values and get the answer. Okay, so over here it's 3 by 2, number of moles is 2, the value of gas constant is 8.31, and the temperature is 320. When you will solve it, it will come out to be 8000 joules, or which can also be written as 8 kilojoule. So this is how we can get the answer, and this is the basic difference between kinetic energy and internal energy. Now when you will see the values, look at this value. This is the average kinetic energy per particle. Understand that, per particle. And this is the total energy of the system, of the gas, of the whole gas. So when we are finding the total internal energy of the gas, then we consider the number of moles. Otherwise, we do not consider the number of moles in average kinetic energy calculation. I'm giving more focus continuously on that so that you understand the difference between both the things, and just watch this video one more time if there is any conceptual misclarity, so you will get it clear, and hopefully you will be clear after watching this video.